All right, kids. We are going to start into section 11.4 today, and there is a ton of information here, okay? So you really got to be in the ball, and this is something that you're going to have to refer back to. This sheet looks kind of daunting at first, this opening page. I mean, look at all this stuff, and you're going to need to know all these different types of angles. The good thing is, I know that there's, 7 rows there, but it's not like it's 7 different things you have to memorize because some of them are very similar. They behave the same. We'll talk about that here in a second. And so we're going to be talking about angles. And here we're going to start off with something that you already know because we've been talking about this for a little while. And that is a central angle. Nice and easy. The vertex is at the center of the circle. The sides are made up of radii. And this measure, what we're going to do is we're going to say, with respect to the intercepted arc. Remember, intercepted is just the created arc. So we're talking about how does this angle here, this central angle, relate to this arc? And of course, we already know that those measures are the same. So, here if we had 70 degrees, they're both 70 degrees. Nothing new there. Done that before. Okay, and then the next one, we talked about this a couple lessons ago as well. This angle is called an inscribed angle. And we did a little proof on this relationship that we're going to get to in a second. Now, this differs from the central angle because the vertex of this angle is on the edge of the circle, right? Let me fix this. It's on the edge of the circle. These sides are made up of chords. Now, I don't know if, hopefully you remember, the inscribed angle is half of the intercepted arc. Okay, half of the intercepted arc. And we did a proof, I think it was back in the 11.2 lesson. Did a little short improvisational proof there, and there's some stuff in the textbook as well. So what that means, of course, if this arc is 80 degrees, this angle down here would be 40. Okay, the next thing is a tangent chord angle. Tangent chord angle. And we're talking about this angle right there. Now it behaves just like the inscribed angle. That angle is also on the circle. All right. Now it's made up, of course, of a chord and a tangent. Remember, this angle goes all the way from this chord to the tangent. It doesn't stop at the circle. You can't have an angle that stops at a curve, okay? Now this is also half of the intercepted arc, all right? So if I had, something like that, there's my chord, there's my tangent, there's the tangent chord angle, okay? If this big arc from here all the way to here is 300, then of course this big angle in here has to be half, 150. And that should make, and then of course if that's 300, this would be 60, and that would be 30, of course. Kind of see the relationship there, because these two angles are supplementary, they add up to 180. but these two angles also intercept these two arcs, which together make the whole circle of 360. So the nice thing about these two things is they behave the same way. If the angle is on the edge of the circle, it doesn't really matter if it's called inscribed or tangent chord, they're going to be half the intercepted arcs. Okay, the next one is a chord-chord angle. And so obviously it's made up of two intersecting chords. Now this vertex is in the interior of the circle. And the sides are made up of parts of chords. Okay. Now, I'll explain this more in a second, but this angle here is going to be half the sum of the intercepted arcs. So if I'm talking about this angle here, okay, that means we're talking about this arc and this arc. Remember, these are vertical angles. So we're talking about the arcs opposite those vertical angles. So this angle here is going to be half of this sum. Works the other way too here with this big obtuse looking angle. You know, this angle here would be half the sum of this big arc and that big arc. So here, let's just do a quick, my document will come back in a moment. There it is. Okay, so let's say we had something like this. If this is 120 and this was 80, angle X, of course, would be 120 plus 80 over 2. Okay. And that would be, of course, 100 degrees. Okay, even though it doesn't look like it. I really should have used other numbers there. Let's change that to just so stuff looks a little bit better. You know, that arc looks pretty small. Let's call that 20. So then this would end up being 70 degrees for X. Now that's the only angle that's going to be on the inside, the chord-chord angle. Okay, half the sum of the intercepted arcs. Now we still got three more. I know it's a lot of stuff here, but this is the last three. You know, the good thing is all of these behave the same way. Okay, watch what's going to happen here. Here we're talking about this angle out here, and that's called a secant angle. And then this next thing is called this angle here. That is a tangent secant angle. And the last one here we're talking about this angle here, and that's a tangent angle. Now I'm doing all three of these at the same time because I'm hoping you notice the commonality here. The vertex for all of these angles is where? It's the exterior of the circle. Exterior of the circle, all three of them. Obviously, this is made up of two secants. This is made up of a tangent and a secant. This is made up of two tangents. All three of these angles, though, is going to be half the difference of the intercepted arcs. So, you know, if I'm talking about this angle, the arcs would be this one here and this one here. So you would subtract those two arcs and divide by 2 to get this. Same thing here. Subtract this one minus this one, divide by 2. Subtract this one and this one, divide by 2. Okay? My pen ran out. Let me see if I can get this going here. This has been a problem recently. Always happens in the middle of a video. There we go. I think the battery contact isn't that good. Anyway, let's say, if this is 120 and this is 20, angle X here would be 120 minus 20 over 2, or 50 degrees. And the other ones, I'm not going to do this one. I mean, well, I'll do it. I'll leave the last one. So here we're talking, let's say this is 150 and this was 50. Okay. And this is X. 150 minus 50 over 2, of course, gives me 50 degrees, which is X. All right. Tangent, tangent. So if this was 200, which means this has to be 160. Obviously, 200 minus 160 is 40. Divide by 2, my X is 20 degrees. So it's a lot of information there. But again, there's 4 different types, and 1 or 2 of them you already knew. Remember, central angle, that's easy. That's just equals the arc intercepted. Inscribed angle we talked about before. It's half the intercepted arc. Now we have a tangent chord angle as well, but it behaves the same way as the inscribed. Angles that are on the edge of a circle behave the same. Okay, these behave the same. You have this chord, which we hadn't talked about before. This is brand new, right in the middle. It's half the sum, and then these last 3 that all have their angles on the outside, those are going to be half the difference. So these all work in conjunction with each other. But yeah, you definitely want to be comfortable with this stuff. This might be something you have to look at again and keep this thing handy the next couple of days. So here's some exercises. If you want to try to do these first 6 problems, A, B, C, all the way through F, do it first. They're pretty quick, kind of feel good problems, no big deal. Remember angle A, I'm going to do them right now, but if you want to try them first. If this is 220, this would have to be, whoops, that's not right. This would have to be 140. Angle A is a tangent chord, so it has to be half. Angle E is on the outside, so it's half of the difference. So 160 minus 50 is 110 divided by 2. Angle BEC, right in here. Well, I'm not going to worry about that yet. Let's find angle BA first. Let's find this first. That's a chord angles, half the sum. Obviously, X is going to be 100 degrees because 120 plus 80 over 2. And then, of course, BEC is supplementary to that. Hoping that this is pretty simple. Angle C is on the outside. Now, what's key here is you have to recognize, hey, that's the center, so that means this thing's a diameter. So this is a semicircle down here. That would be 180 degrees. If that's 120 and that's 10, this would have to be 50. So angle C, outside, half the difference, 50 minus 10 is 40. Divide by 2. There you go. Okay. Let's see, next one here, what do we got? We have, this is 75. So that means this one's a little bit more interesting. That's a tangent chord angle. So this arc has to be double 150. Now remember, these tick marks mean that these 2 chords are congruent. This goes back to a few days ago as well. Congruent chords imply congruent arcs, so that's 150. Well, you got 300 accounted for, so this must be 60. And arc 60 degrees, they're all set. If we had asked for angle B, angle CBD, I should say, that would be 30 degrees, of course, half. And let's see here, arc AB. So we got to do a little bit of work. Remember, this 50 is on the outside. So 50 equals arc AD minus 75 over 2. So we do a little bit of solving here. So AD would have to be 175. And if that's 175 and that's 75, together we got 250. So the remaining arc up here has to be 110. I'm hoping those are pretty easy and that you got most of them yourself. You may need a little assistance on E. No big deal. Okay, ABC is inscribed in a circle. All the sides are chords. And we're asked to find. So let's just draw this out. But something that's smart is to look at this. If you look at these measures, I'm hoping you realize that this is going to be a 30, 60, 90 triangle. Okay. Has to be based on those relationships. So that means one of the angles is going to be 90 degrees. Now, if an angle is 90 degrees, I'm going to get ahead of myself here a little bit, but come on. If an angle is 90 degrees, that means one of your chords must be a diameter. And I hope this makes sense. Let me show you why. Okay. Remember, we knew we had a 30, 60, 90 triangle. So if that's 90, you see that's an inscribed angle. So that means this arc opposite it has to be 180 degrees. Well, if you have a 180 degree arc, then of course that must be a diameter. So you have that situation there. Now, this was what, 30? This is 60. And they're asking for arc BC, so that of course is going to be 120 degrees because this 60-degree angle is an inscribed angle. It's intercepting this arc. Has to be twice, so that's 120. Okay. Still got a little bit more stuff. Sorry, there's a lot of information here today. A lot of information. We're not really doing a proof here. We're just going to kind of quickly talk through a new theorem. Take a look at this. We're asked to prove that angle X and angle Y are congruent. But what kind of angle is angle X? Hopefully you recognize that angle X is on the circle. It's made up of two chords. This is an inscribed angle. Angle X intercepts this arc. Angle X is half that arc. Then you look at angle Y and you recognize that angle Y is also an inscribed angle. And angle Y intercepts the same arc AB. So if angle Y is half of AB and angle X is half of AB, we know that angle Y and angle X have to be congruent. Okay. So it does lead to a theorem if inscribed angles intercept the same or congruent arc or arcs, then they are congruent. And remember, what was the other angle that was just like an inscribed angle? It was the tangent chord angle, right? If tangent chord angles intercept the same or congruent arcs, then they're congruent as well. And you can actually mix and match those. If you have a inscribed angle intercepting the same arc that a tangent chord angle intercepts, they're going to be congruent as well, just for what we talked, for the reason that we talked through up here. Okay. This next thing, we're almost done. If all angles inscribed in semicircles have the same measure. Well, that's what we talked about up here, like angle C. Angle C was a right angle, right? It intercepted the semicircle. So all angles inscribed in semicircles are 90 degrees. Nothing fascinating there. And I got one little proof to do down here. This is kind of cool. So we're given that PT and PS are tangent to circle O. Now remember, back in section 11.1, I think we talked about these tangent segments would have to be congruent then. And these, of course, are radii, so those are congruent. And then remember, any radius to a point of tangency is a right angle. So we have a kite here, right? We have a kite. Now check this out. That's 90 and that's 90, so 180 degrees of the kite is already accounted for. So we know that angle X and angle Y must equal 180 as well, because the sum of the angles of a quadrilateral have to be 360. Now, angle X is a central angle, and that means that arc TS, arc TS has to be X as well. So angle P plus arc TS has to be 180. So what that leads to is another theorem. Remember, angle P was a tangent-tangent angle. A tan-tan angle and its minor arc add to 180. Obviously, that tangent-tangent angle creates this major arc here, creates this minor arc here. But the minor arc and the tangent-tangent angle have to add to 180 degrees. Okay, sorry that one was so long. I'm sure you guys are sick of listening to me. But there's lots of information in this chapter and in this section in particular. So make sure that you're comfortable. Go back and look at this stuff. Remember, there's good information in the textbook as well. Okay. But yeah, there's a lot to take in here. All right, that's it for now.